Now let's talk about a couple of different kinds of special binomials that we need to be able to recognize. And the first one is called a difference of squares. Now remember, the word difference means minus, and you know what a square is. It's a number times itself. So a difference of squares is one square minus another square. For example, x squared minus 9 is a difference of squares because these are both squares. Now, a difference of squares can always be factored into a sum and a difference of the same two terms. You probably remember from section R.3, we multiplied a sum and a difference of the same two terms together, and we got an answer like this. Well, that means that an expression like this can always be factored back into a sum and a difference of the same two terms. So if we factor this, x squared would be x times x, and the minus 9 would have to be a positive 3 and a negative 3. Now notice that if we did outer plus inner, they would add up to 0, which is what we need because we don't have a middle term here. And notice that the different signs here produce the negative on our last term that we need. So this is how we factor a difference of squares. And the most important thing about factoring a difference of squares is learning to recognize them when you see them. They're easy to factor, but you will only know to factor them if you've learned to recognize them. So that's a very important part of learning to factor, is learning to recognize what kind of expression you're working with. So here in part A, we have 9a squared minus 16. Notice the instructions say factor each expression if possible. So first I want to ask myself if this is a difference of squares. I see the minus sign, so it is a difference. And now I need to make sure it's a difference of squares. 9a squared is 3a times 3a, so this is a square. 16 is 4 times 4, so this is a square. So that tells me this is a difference of squares, and I can factor this into a sum and difference of the same two terms. 9a squared is going to make 3a times 3a. Minus 16 is going to make plus 4 and minus 4. And that's it. That's all there is to factoring a difference of squares. And like I said, the most important thing is that you learn to recognize them when you see them. Here in part B, we have x squared plus 7. And now remember, a difference of squares has to contain a minus sign because difference means minus. And this is not a minus, this is a plus. So this is not a difference of squares. And in this case, this is an expression that cannot be factored at all. So when we have one that can't be factored at all, we say it's prime. So this expression is prime. And let's look at part C. Here we have 3x squared minus 75. Now this is not a difference of squares as it sits right now. 3 is not a perfect square and 75 is not a perfect square. There's no whole number times itself that will make 75. But we do see that there's a GCF here. Both of these terms can be divided by 3. So we need to factor out 3 as our GCF. 3 times x squared would produce that term, and 3 times negative 25 would produce that term. And once we get the 3 factored out, we can see that what's left in parentheses is a difference of squares. It's a difference because of the minus sign. And we have a square here and a square here. So square minus square. This is a difference of squares. And how do we factor a difference of squares? We factor it into a sum and difference of the same two terms. So x squared is going to give us x times x. And then for the minus 25, we need a plus 5 and a minus 5. And that's it. Notice that we could not do this one until we factored out the GCF. So it's very important that you always look first for a GCF. If there's a GCF, factor it out first, and then you'll be able to see if you can take another step. Now let's look at how to factor another type of binomial. The next one is a difference of cubes, and we also have a sum of cubes. We're going to take them actually both together because they're very similar. A difference of cubes or a sum of cubes. So you know the word difference means minus. We just talked about that. A difference of cubes is one cube minus another cube. For example, we could have x cubed minus 27. Now you may know that 3 to the third power is 27, so 27 is a cube. And so here we have cube minus cube. This is a difference of cubes. And a sum of cubes is one cube plus another. So for example, x cubed plus 27, cube plus cube. So this is what we mean by difference of cubes and sum of cubes. And now I'm going to show you how to factor these expressions. Factoring a difference of cubes and a sum of cubes is a little more complicated than what you can do by trial and error. So we have formulas, and you'll need to learn these formulas, but fortunately they follow a really easy pattern, and I'm going to show you how to do it. To factor the difference of cubes, you'll first need to just set down a binomial-sized pair of parentheses and a trinomial-sized pair of parentheses. See, this is different from any other factoring we've done so far. So what goes in this binomial-sized pair of parentheses? Well, you first need to figure out what this is the cube of and what this second term is the cube of. So this first term is the cube of x, and the second term is the cube of y. So that's what goes inside the parentheses, x minus y. And so notice that because my expression contained a minus, my binomial also contains a minus. Now the trinomial here is made of three terms, but the three terms are made of these two numbers that you'll have right here. So this first term needs to be x times itself, so x squared. Now if you have a minus here, you're going to put a plus here. And the middle term is going to be this one times this one multiplied together. And then for the last term, you're going to do this second term times itself. So negative y times negative y would be plus y squared. Okay, so one more time. You're going to set down a binomial size pair of parentheses and a trinomial size pair of parentheses. Whatever this is the cube of goes here. Whatever this is the cube of goes here. And once you get these two numbers, you can fill in your trinomial by saying first term times itself goes here. First term times second term goes here, but the sign needs to be opposite. So if this was a minus, this needs to be a plus. And then this term times itself goes here. And that's how you do it. Now the sum of cubes formula is very, very similar. It's built the same way, just the signs are different. So we're going to set down a binomial and a trinomial size pair of parentheses. So whatever this is the cube of goes here. And then this is a plus, so I'm going to put a plus here. And then whatever this is the cube of goes here. Now build this trinomial the same way. X times x needs to be x squared. If this is a plus, this needs to be a minus. X times y goes here, and then your last term is going to be y times y, so that's y squared. And these are the formulas. And you do need to learn them, and you need to memorize them, but they're not really that hard to memorize once you've gone through the pattern a few times and you've practiced with it and you get used to how it works, you'll be able to do it. Now, I've recopied the formulas here, but I want to give you a little acronym that will help you remember how to put the signs in here. And the acronym is SOAP. So in the acronym SOAP, the first letter is S. So S stands for same sign as in the problem. Notice that in both of these formulas, the sign in the binomial is the same as what was in the problem. So if your problem has a minus, your first binomial is going to have a minus. If it has a plus, your first binomial is going to have a plus. Then O stands for opposite sign. So your next sign needs to be opposite from what came before, opposite from what's in the problem. So if your problem has a minus, this middle term is going to be plus, and if your problem has a plus, this middle term is going to be minus. And then AP stands for always positive. So SOAP, same, opposite, always positive. And this is how you remember the signs in your sum of cubes formula and difference of cubes formula. So let's practice. And again, just like with difference of squares, it makes it a lot easier to factor a sum of cubes or difference of cubes if you know the cubes. So you're not going to recognize these if you don't know the third powers of some of these numbers. Here I have x to the third minus 125. 125 is the cube of 5. 5 times 5 is 25. and times another 5 makes 125. So this is the cube of 5. And so I can recognize this as a difference of cubes. This is the cube of x, this is the cube of 5. So that tells me I can factor this by putting down a binomial and a trinomial. And we said this is the cube of x, so x goes here. Same sign is in the problem. Remember SOAP, S for same. So same sign is in the problem. And then this is the cube of 5, so 5 goes here. Okay, now we're going to build our trinomial. X times itself gives us x squared. Opposite from what's in the problem, so this was a minus, I'm going to put a plus here. X times 5 is 5x, so that's how we got the middle term. And then this binomial times itself will give us a plus 25 for the end. And that's how you factor that. Now, sometimes students will ask, do we ever have to worry about factoring this trinomial? And the answer is that this trinomial is going to be prime, so you will not be able to break it down. So your final answer on a difference of cubes or sum of cubes is always going to be a binomial times a trinomial. Okay, on part B, here we have x to the third plus 64. So we need to ask ourselves, is this a sum of cubes or a difference of cubes? And the answer is, well, it is a sum. So is 64 a cube? Well, the answer is yes. 4 times 4 times 4 is 64. So this is the cube of x and this is the cube of 4. And that means I can factor this as a sum of cubes. We said this is the third power of x, so x goes here. Same as in the problem, so a plus goes there, and this is the cube of 4, so a 4 goes here. Now to build this trinomial, we do first term times itself, so that's x squared, and then we do opposite sign, and then we say x times 4 is 4x, so the middle term is 4x, and then last times last makes 16, so we put plus 16 there on the end. Let's try x to the third minus 1. So a lot of people don't recognize it, but of course 1 is a cube because 1 times 1 times 1 is 1 to the third, and that's still 1. So this is a difference of cubes, and we can factor it into a binomial times a trinomial. So this first term is the cube of x, so that goes here. We need a minus sign here. And then this is the cube of 1, so 1 goes here. Now for the trinomial, x squared is going to go here. Opposite sign for what's in the problem goes here. X times 1 is 1x, so I just put x. I didn't even write the coefficient. And then last times last makes plus 1 for the last term. So that's the factoring for part C. Now for part D, if you haven't tried one on your own yet, I recommend that you pause the video and try working it out yourself and see if you get it right. And if you do, that'll give you some confidence to do well on your homework. But here we have a sum of cubes, so we have x cubed plus 27, and 27 is the cube of 3. So I know I can factor this into a binomial times a trinomial. This is the cube of x, so I'm going to put x here. Same sign as in the problem. And then this is the cube of 3, so I'm going to put a 3 here. Now for the trinomial, x times x gives me x squared. Opposite sign, and then x times 3 is 3x. And then last times last is going to make plus 9. And that's it for how to factor a sum of cubes and a difference of cubes. Now, I would like to go through multiplying these factors back together with you just one time so that you can see that the factoring really does work. I'm not saying that you have to do this on every sum of cubes or difference of cubes that you factor, but I think it's important that you see it at least one time so you'll understand why it has to be this way. So what I've done is I've taken x cubed plus 27 and I've factored it according to the formulas that we learned in the last couple of slides. Alright, now let's double check our work by multiplying these back together and we'll see what we get. Okay, first distributing the x. X times x squared is going to be x to the third. X times negative 3x is going to be negative 3x squared, and x times 9 is going to be plus 9x. Now distributing the 3, 3 times x squared is going to give us positive 3x squared. 3 times negative 3x is going to give us minus 9x, and 3 times 9 is going to give us plus 27. So when we get ready to combine our like terms, you can see that our x squared terms are going to add up to 0, and our x terms are also going to add up to 0. And so all that's left here is x to the third plus 27. And I think it's really good for you to see this because a lot of students mess these signs up, even though I gave you that acronym. And we said SOAP, same, opposite, always positive. We know that we're supposed to do the signs that way, but a lot of students still get the signs mixed up. And I want you to notice that what's making these middle terms add up to 0 is that we have one sign here and the opposite sign here. If you didn't have opposite signs here, you wouldn't get opposite signs here, and your middle terms wouldn't add up to 0. So it's real important that you make sure you understand how the signs work. Okay, and that's it. Now let's move ahead and look at a factoring strategy. So we need a general factoring strategy that we can use to approach any factoring problem that we run into, because we've got all these different methods of factoring now. Okay, so this is the strategy I want you to follow. It's really simple. The first thing you always need to do when you're factoring is always look for a GCF first. And I think you've probably noticed that we always do that in the examples that we have. Anytime there's a GCF, we factor that out first. There are two reasons for that. One reason is if you have a GCF, sometimes you can't see how to do the next step until you remove that GCF. And the other reason is pulling out the GCF can make the numbers smaller, and so it makes the problem easier. So you're going to have to do it sooner or later. You may as well do it first and make the rest of the problem easier. The rest of the steps are all based on how many terms your problem has. So if the remaining expression has 3 terms, then that's a trinomial, and you're going to try to reverse the FOIL process so that the trinomial becomes the product of 2 binomials, and we have seen that before. If the remaining expression has 2 terms, then you've either got to have a difference of squares, a sum of cubes, or a difference of cubes. So you need to recognize which situation you're in and use the appropriate method. If you've got a binomial and it's not a difference of squares, a sum of cubes, or a difference of cubes, then it's not factorable any further. So you may have pulled a GCF out of it, but you won't be able to do any more steps if it's not one of these things. Now, if you've been through the first 3 steps and there's no GCF and there's no other factoring that can be done, the expression is prime. Remember, we said prime means that no factoring at all can be done. And one more thing that I want to add, it doesn't say it here, but you need to be in the habit of always checking your work to see if you have left any factors that can be factored further. For example, if your answer contains a difference of squares, you need to factor that difference of squares as well. So now we're just going to practice on several different expressions, and each time we're going to think through the factoring strategy that we just talked about. So remember, first we check for a GCF, then we factor based on the number of terms, and if we can't do any factoring at all, we say that the expression is prime. Okay, here I have 18m to the third plus 3m squared minus 6m. And step 1 is check for a GCF. So is there anything that goes into all 3 of these terms? And the answer is yes. 18 and 3 and 6 can all be divided by 3. And we also notice that m is common to all 3 terms. So since m is common and the smallest power of m is m to the first is going to need to be part of my GCF. Okay, now in parentheses, I need room for 3 terms. So 3m times 6m squared would make 18m to the third. 3m times m would make 3m squared. And 3m times negative 2 would make negative 6m. So this is our first step. Now notice that what we have in parentheses is a trinomial. So we are obligated to try to factor that trinomial into 2 binomials. It might work and it might not work. If it doesn't work, then this will be our final answer. But if it does work, then this will be our final answer. So let's give it a try. 6m squared could either be 3m times 2m, or it might be 6m times 1m. I have to try all different combinations until I find one that works. So I'm going to start by trying 3m times 2m. And then I look at the sign of the last term, and it is negative. So that tells me last times last made a negative number. That tells me these signs need to be different. So right now I don't know if the plus needs to go here or here. I just put it down as different signs, and then we can fix it later if we need to. Last times last is 2. So of course the numbers I can put here are 1 and 2, but I know in advance that I cannot put the 2 here, because if I put the 2 here, that would create a GCF in that factor. So I'm going to put the 2 here and the 1 here, and let's see what happens. So I need for outer plus inner to add up to positive 1m. Let's see what we get. 1 times 3m will be 3m. 2m times negative 2 will be negative 4m. 3m minus 4m is going to add up to negative 1m, but I need it to add up to positive 1m. So what that tells me is my signs are backwards. So I'm going to just switch the minus and the plus, and we don't even have to recheck. Like, we just automatically know that now it's going to work. But you can recheck it if you want to. So this is our final answer for part A. Let's look at part B. So first we need to check and see if we have a GCF. Now I notice that I have a 2 here. So 2 goes into both of these terms, so I'll factor out a GCF of 2. And in case you're wondering if x should be part of the GCF, notice that this second term does not have an x, so x is not common. So x is not part of the GCF. 2 times x squared will make that term, and 2 times negative 36 will make this term. Now, for x squared minus 36, we notice that this only has 2 terms. So it's either got to be a difference of squares or a difference of cubes. It's not a sum because I don't have a plus sign. But is it squares or cubes? Well, you see the square here. This is the second power, so it's squared. And you know that 36 is 6 times 6, so this is a difference of squares. We're going to keep the 2 in front and break this binomial down into 2 smaller binomials. So x squared becomes x times x, and then the negative 36 becomes positive 6 and minus 6. And that's it. Here in part C we have 144x squared plus 121. Now notice that there is no GCF here because 144 is 12 times 12 and 121 is 11 times 11. So they have no common factors. And x is not common, so we cannot factor out a GCF. So the next thing to do is ask ourselves, do we have a difference of squares or a difference of cubes or a sum of cubes, or is it something else? Because if it's something else, we won't be able to factor it all. Well, here I have a plus, so I know this is a sum, and these are both squares, so I know this is a sum of squares. And sum of squares is not one of the things we can factor. If you tried to factor it, you would see that you would never be able to get rid of your middle term and keep the last term positive 121. So it just won't work. So a sum of squares can never be factored, and we weren't able to do anything to this problem, so this one is prime. Now let's look at part D. So here we have 3x squared plus 15x plus 6. And the first thing we need to do is check for a GCF. I see that 3 goes into all 3 of these coefficients. So we're going to factor out a GCF of 3. Notice that x is not common because the last term does not have an x. So here we go, factoring out a GCF of 3. 3 times x squared would make 3x squared. 3 times positive 5x would make 15x. And 3 times 2 would make 6. So now we have 3 times x squared plus 5x plus 2. Now this is a trinomial in the parentheses, so we are obligated to try to factor it into 2 binomials, and let's see if we can do that. So x squared has got to be x times x. The signs have got to be plus and plus because last times last is a positive, so that tells me the signs need to be the same, and they both have to be the same as the middle term. So these plus signs are good. Now the only numbers that we can put here and here for 2 would be 1 times 2. And notice that either way we arrange them, we're never going to get the 5x we need for the middle. So there are no other choices that we can use for 2, and the choices that we have will not get us the middle term. So that tells me that this factoring is not possible. So I'm just going to erase that step, and this becomes our answer. Now, a lot of students would be tempted to write prime down here as the answer because they tried to do that factoring and it failed, so they think that it's prime. Now, the trinomial is prime, but I'm not going to write the word prime here because if I write the word prime, I'm saying my answer is prime. In other words, there's no factoring that I can do, but I've already done some factoring. So this expression that we started with was not prime. We did factor a 3 out of it. That's as far as we were able to go, but I can't say that it's prime because I was able to do one step. So this is our final answer. And here we have part E. So we have 12x squared minus 8x. Now, we do have a GCF in this expression, so let's see what it could be. 12 and 8 can both be divided by 4. And notice that the x is common, so I need an x in my GCF. And now notice that we need room for 2 terms in the parentheses. So here are my empty parentheses. Now 4x times 3x makes 12x squared, and 4x times negative 2 makes negative 8x. So we came up with 4x times 3x minus 2. What's left in the parentheses is 2 terms, but it is not a difference of squares, and it is not a difference of cubes or a sum of cubes. So nothing can be done to this, and so this is our final answer on part E. And let's look at part F. Here we have 6x squared minus 18x minus 60. So always check for a GCF. I notice that 6 can go into each of these numbers. And I notice that x is not common, so the GCF will just be 6. And inside the parentheses, I need x squared minus 3x minus 10. You can see that if I redistribute the 6, it goes back to this form, and you can see that these terms no longer share a GCF. So this is good so far. And now this is a trinomial, and we need to try to break it down into 2 binomials. So keep your GCF and just put down your 2 empty pairs of parentheses. X squared is going to be x times x. The signs in the binomials need to be different so that last times last can be a negative. And then 10 can only be 5 times 2, but I'm going to be careful and put the 5 with the negative sign and the 2 with the plus, so that outer plus inner will add up to negative 3x. And so this is our final factoring for part F. Now, again, I've said this before, but factoring is a learned skill. It's something that only comes by practice, but if you will take the trouble to get good at factoring, then you'll be able to do anything in algebra, and you won't have nearly as many problems as you would if you didn't know how to factor. Knowing how to factor makes everything easier. So this is one place where I really want to encourage you to dig in and make sure that you build up these skills. You need to really understand factoring well. So good luck with that, and I'll see you in the next section.